Okay, let's try an example that's a bit harder. Make sure you watch my first video to see the basic setup, because I'm going to skip a few things now. Remember that our solution, though, looks like something of this form: n equals 0 to infinity, a sub n, x to the n, for a series solution. The difference now is that we have some extra functions tacked on to our derivatives. That's okay, we'll handle those when we get there. So in our problem we have no derivative, the first derivative, and a second derivative, so we're going to need the first and second derivatives. So let's do that again. The first derivative is, remember that the sequence index is up 1 now, so we start at 1 instead of 0, and we have x to the n, excuse me, I wrote that wrong. A sub n times n, x to the n minus 1. And we'll need our second derivative as well. Y double prime equals our index at 2 this time. A sub n times n minus 1, x to the n minus 2. So we'll plug this in like before. 1 plus x squared times the second derivative. And again, there are many places you can make mistakes in these problems, so just be very careful. Minus 4x, plugging in the first derivative now. A sub n, x to the n minus 1, and then the no derivative, plus 6 times this series. A sub n, x to the n. And that's, of course, equal to 0. So now we have to clean this up, get everything into one series, and get all these x's to match. So in order to do that, we have to get rid of these coefficients. 1 plus x squared, negative 4x, and 6. So we're going to distribute that in. Now let's think about if we were to distribute this coefficient to this series. Or think about it backwards. Think about distributing the series to both of these terms. Well, the first term would just be 1 times the series, so we would just get the series again, starting at n equals 2 to infinity, a sub n times n minus 1, x to the n minus 2. And then when you multiply x squared by this series, we'll have a sub n minus 1. You multiply the x squared inside, you'll have x squared times x to the n minus 2. So that's x to the 2 plus n minus 2. Remember, when you multiply numbers with the same base, you add the exponents. So x to the second times x to the n minus 2 is x to the 2 plus n minus 2. And we'll simplify that in a moment. Same thing with this third series now. Plus series from n equals 1 to infinity. And this becomes negative 4 a sub n times n x. Okay, now we're multiplying x to the first times x to the n minus 1. That becomes x to the 1 plus n minus 1. And then our last series here, we'll just push the 6 inside. So this is good. We'll clean this up a bit more. A sub n times n minus 1, x to the n minus 2, plus this second series, n equals 2 to infinity, a sub n minus 1. This becomes x to the n, canceling these 2's, plus this series, n equals 1 to infinity, negative 4, a sub n, again this becomes just x to the n, plus last series, n equals 0, infinity, 6 a sub n, x to the n, all equals 0. So this is real nice. We have x to the n here, x to the n here, x to the n here. That's our first step, is to get all those x expressions to match. There's a problem here. This one starts at n minus 2. So we're going to do our reindexing trick like before, and we're going to let n go to, n minus 2. We want n minus 2 to just become capital N, which means n is going to become capital N plus 2. Now we can rewrite this first series, plugging in for little n, capital N plus 2 equals 2, a sub capital N plus 2, capital N plus 2, subbing in for little n, and then capital N plus 2 minus 1 is just n plus 1, x to the n plus 2 minus 2, and that's the first series. We'll rewrite the rest of the series as well, and again we'll just switch to capital N's for convenience. If I miss any capital N's, just keep in mind they should all be capital now. So again, make sure you're checking your work on every step. Okay, so if we did this right, all our x terms should match. So if you look here, you'll see x to the n plus 2 minus 2. That just becomes x to the n. And then if you look here, n plus 2 equals 2. Well, that means n equals 0. Okay, so we've got all our x's matching, which is great. Now we have to make sure the indices at the bottom match. If you don't, unfortunately, but that's okay. You're always going to want to follow the same procedure, though. You're going to look at the index that has the highest term and try to get everything to match that. So n equals 2, we want to start these series at n equals 2 as well. The only way to really do that is to just write out the first 2 terms in this expansion and then collect the rest as a series, and you'll see what I mean here in a moment. So the first term in this expansion corresponds to capital N being 0, so the first term will be a sub 2 times capital N is 0, so times 2 times 1, so times 2, x to the 0. That's the first term. The second term will be capital N equals 1, so plus We write those out. Plus a sub 3 now, capital N is 1, times 3 times 2, which is 6, x to the first, plus the rest of the series. But now our series starts at 2, since we took care of those first two terms. A sub n plus 2, these should be capital. Okay, this series is fine. This middle one, we'll just rewrite that. Okay, I'm looking at the third series here. We just have to take care of the first term in order to get the series to start at n equals 2. So let's write out the first term for that one. Negative 4 a sub 1 times 1 times x to the first, plus the rest of the series, n equals 2 to infinity, a sub n, oh, writing the wrong one, negative 4 a sub n, capital N, x to the n. Now when you look at this third series, again we have to write out two terms before we can get to n equals 2. So we'll write those out. Our n equals 0 term is 6 a sub 0 x to the 0 plus our n equals 1 term, 6 a sub 1 x to the first plus the rest of the series, n equals 2 to infinity, 6 a sub n x to the n. All of that is equal to 0. So this looks like a big mess, and it kind of is. That's alright. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. Let's just rearrange these to be a little more neat. We'll put all our actual terms first and then our series second. So let's write out all of the terms. A sub 2 times 2. X to the 0 is just 1. Takes care of this one. Plus a sub 3 times 6. X takes care of that. Minus 4 a sub 1 x takes care of that. Plus 6 a sub 0. X to the 0 is 1. Takes care of that. Plus 6 a sub 1 x takes care of that. And then plus our 4 series. Let's just label these series. This will be series 1. This will be series 2. Series 3. Series 4. We don't need those for the time being, so we'll just write these here. Plus 1, plus 2, plus 3, plus 4. Equals 0. So So let's clean this first part up a bit. This is 2a2 plus 6a3x minus 4a1x plus 6a0 plus 6a1x. Okay, we'll factor out x from the terms that have x, and then we'll keep the constants together. So 2a2 plus 6a0 plus factoring out x from this term, and this term, 6a3 minus 4a1 plus 6a1. Plus the series equals 0. Now, if this left side is going to be equal to 0, that means all the coefficients here on x has to be equal to 0, and then the constants have to be equal to 0 as well. So we can set up two equations here and get 2a2 plus 6a0 equals 0, and 6a3, see, adding these two terms, we get plus 2a1 equals 0. We can solve these, and this will tell us 2a2 equals negative 6a0, or a2 equals negative 3a0. Second equation tells us 6a3 equals negative 2a1, which means a3 equals negative 1/3 a1. Now, let's look at the series as a group. That sum also has to be equal to 0 because, well, we'll clean that up a bit first. So let's write out these series. Infinity. Rewriting the series carefully. So like before, we're going to add these series because they all have the same indices. We can add them and factor out the x to the n. So let's do that now. Factor out the x to the n first. That's the first series, and then factoring out x to the n from the second, we get a sub n times n minus 1. Now the third series, negative 4 a sub n, and then from the fourth series, 6 a sub n, and that's everything. Okay, and like before, we need this series, this sequence of coefficients to be equal to 0, so that the whole left side of the equation will be equal to 0. So we're going to set that equal to 0. Okay. Solving for the higher power index, we're going to move these three terms to the other side of the equation, and then divide by n plus 2 and n plus 1. So a sub n plus 2 equals negative a sub n minus 1 plus 4a sub n times n minus 6a sub n, all divided by n plus 2, n plus 1. And we'll clean this up. If we multiplying this out, we get n squared minus n. Adding these two terms together, minus 2 a sub, oh, so we can't add those two terms together, they're not like terms. So we'll leave those alone, plus 4a sub n times n minus 6 a sub n. We may as well just leave the bottom term factored, no problem. N plus 2, n plus 1. Okay, from the numerator, we'll factor out negative a sub n. Negative a sub n from all three terms. We'll be left with n squared minus n. Factor out negative a sub n here, we're left with minus 4n. And then for the last term, we're left with plus 6. N plus 2, n plus 1 is equal to negative a sub n. Now this is negative 5n, and you can see that this factors into capital N minus 3, capital N minus 2, all over n plus 2, n plus 1. So this is our recursive formula for our next two terms in our sequence. So let's write out the first few terms in our infinite series. Again, like before, we'll say a sub 0 equals a sub 0, a sub 1 equals a sub 1, a sub 2, well, that's corresponding to capital N being 0 now. A sub 2 is equal to negative a sub 0 times capital N is 0, so we're going to plug in 0 everywhere here. negative 3, negative 2 divided by 2 times 1, and we'll get negative 6a0 over 2 is equal to negative 3a0. Now in this particular problem we actually already had that. You won't always though, but we had a sub 2 equals negative 3a sub 0. But it's a good way to check your work. A sub 3 now is equal to negative a sub 1. Using the recursive relationship again, this is n equals 1, capital N equals 1. We're going to have negative 2, negative 1, all over 3 times 2, equal to negative 2a1 over 6, which is negative a1 over 3. And again, you have that from earlier. a3 is negative 1/3 a1. So our formula is correct. We'll write a few more. Capital N equals 2. A sub 4 equals negative a2 times negative, looking at the relationship again, negative 1 times 0 all over 4 times 3. Obviously this is just 0. That's kind of nice. N equals 3. A sub 5 is equal to negative a sub 3 times 0 again. So we plug capital N equals 3 in here, we get 0, and then everything else doesn't matter because we just have 0. So this is 0. Let's think about what's going to happen in our next terms. N equals 4. A sub 6 is going to be equal to negative a sub 4 times some stuff, but a sub 4 was 0. So this is 0. N equals 5. A sub 7 is going to be equal to negative a sub 5 times some stuff, but a sub 5 is also 0. So every term thereafter is just going to be 0, which is really nice. We're not going to have an infinite series solution to this time. We're going to have a nice finite series, not a nice finite solution. So let's write that out. Y of x equals, we'll write out the general expression first, a sub 0 times x to the n, x to the 0, excuse me, plus a1, x to the first, plus a2, x to the second, plus a3, x to the third. I believe that was our last term. Yes, a4, a5, a6, everything else was 0. We only really have these 4 terms. Now we'll plug in the constants that we found. a0 was just a0. X to the 0 is 1. Plus a1 is just a1. We didn't have anything for that. Times x. a2 was negative 3 a0 times x squared. And then a3 was negative 1/3 a1 and then times x to the third. So we'll rearrange this a bit. Factoring out the a0 from the 2 terms that have it, a0 times 1 minus 3x squared. And then factoring out a1 from the 2 terms that have it, a1 times x minus 1/3 x cubed. And this is our solution to the differential equation. Again, A0 and A1 are your constants that you can adjust had they given you some kind of initial condition. So occasionally you do actually get a finite solution from this procedure. Sometimes you'll get just two infinite solutions, sometimes you'll get one, sometimes you'll get none. In this case, we got two finite, which is great.